Welcome. So this question says a Carnot engine operates with a hot reservoir at 120 Kelvin and a cold reservoir at 12 Kelvin. Show that it has an efficiency of 90%. So we're envisaging a system where this is at 120K. And then we have our engine, and our cold sink is only at 12K. And we have work done. And this is Q hot, and this is Q cold, going downwards like that. So we looked at this diagram where we had the heat engine, and the Carnot engine is a idealized engine. It's like the most efficient engine you can get. You can't actually make one, you can approach it. So it tells you how good can it get given these temperature differences. And if we recall for a standard heat engine, we said that efficiency was equal to what you got out, which was the work, over what you got in, which is Q hot. And then we're able to, if you think about it, we can modify that because work equals Q hot minus Q cold. We can have Q hot minus Q cold over Q hot. And that gives us a form which is often quoted, which is Q cold over Q hot, like that. It's just a mathematical rearrangement. For the Carnot, what we have is an analogy, and basically what we find is that the efficiency equals basically the temperature of the hot reservoir minus the temperature of the cold reservoir over the temperature of the hot reservoir. So rather than talk about energies, we can talk about absolute temperatures. And this is 1 minus T cold over T hot. And we see that the bigger the temperature difference, the smaller this fraction, the more the efficiency. That's the take-home message from this. You want a big temperature difference to get to allow a large maximum efficiency for that temperature difference. Now, heat engines follow that. They're not equal to it. The efficiency of the real heat engine is not the same as a Carnot engine. But if you have a big temperature difference, then for any engine you're not going to do so well. So then in this case, this is 1 minus 12 over 120, which is 1 minus 0.1, which equals 0.9. So the efficiency of my Carnot engine is equal to 90% with this temperature difference. So basically, a Carnot engine is a theoretical engine. It's used to calculate how good could the efficiency be with this heat source, temperature of heat source, and this temperature of heat sink. And realistic engines only approach those efficiencies. So there we have it.